Hello everybody, this will be the notes for section 6.5. In the previous section, 6.4, we talked about a way to find or to show that two triangles are going to be similar to each other. And that was the angle-angle similarity. And so what we got for this section, 6.5, two different ways. Now these letters look familiar, side, 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 and side, angle, side. We're not talking about congruency, okay? These are different. There's side, side, side similarity, side, angle, side similarity. And so, again, the idea of similarity. We have corresponding angles congruent. We have corresponding sides with equal proportions, okay? So they're different. All right, so take a second, hit pause, copy these two things down. These are the two theorems for side, side, side similarity and side, angle, side similarity. The proper way to write these things is side, side, side with a little tilde after for the similarity. Same idea for side, angle, side, similarity. That's how you should be writing. So copy this down. Okay, for the first example, question is either of these, or is either triangle PQR or triangle STU similar to triangle XYZ? So I'm just going to go one at a time. I'm going to look at triangle XYZ and compare it to triangle PQR. So all we know are three pairs of sides. So obviously we're going to be going for the side, side, side similarity. But again, what we're looking for is equal proportions between those corresponding sides. So in triangle XYZ, I'm going to start with the smallest side. That's 15. It will correspond to the smallest side of triangle PQR, which is the 21. So the question is, does that ratio equal, go to the medium side length. So in triangle XYZ, that's a 25 compared to the 35 from triangle PQR. And again, does that equal, so a question mark, the longest side. So that's going to be 30 compared to 42. So are these things equal? So I'm just going to try to simplify these fractions. Common factor of 3. So we got 5/7. Common factor of 5. 5/7. Common factor of, well, let's see, 6. Also 5/7. Those are all equal to each other. So triangle XYZ, it is similar to triangle PQR. Okay, we're going to do the same idea for the next triangle. So we're looking at triangle XYZ compared to triangle STU. And so you do the same idea. Just real quick, this one, shortest sides, 15 compared to 15. Does that equal the medium side lengths? 25 over 20, and right away you can see this is not. 15 over 15 is 1, 25 over 20 is not 1. These are not going to be similar. Okay? And so we're just using this side, side, side similarity. All three pairs of corresponding sides, equal proportions. All right, for this problem, it says find the value of x that makes these two triangles similar. So again, looking at what information you're given, you don't know any angles. You know at least something about all three pairs of sides. So that leads us with the side, side, side similarity. And again, similarity. So sides, corresponding sides, equal proportions. So I'm going to compare these corresponding sides. Side 20, it will correspond with side 30. If these triangles are going to be similar, these proportions or these ratios will be equal. And that's going to be x plus 6 over its corresponding side of 21. All right. And so now it's just a matter of solving for x. Okay, this is the x value that will make these two ratios equal. So just doing some cross multiplying. 21 times 20 over 30. I'm going to leave it separate just because I don't have a calculator right here with me. So I'm going to do this in a little bit of a different way. I'm going to break this up into some factors. All right, 21 is 3 times 7. 20 is 2 times 10. We are dividing by 3 times 10. Common factors cancel out. I'm left with 14. That equals x plus 6, subtract 6, x is 8. Okay, here's the x value. That makes these two sides equal proportions. That's the idea of this problem. That's the idea of this section. We've done two examples here with a side similarity. The idea of side angle, side similarity, the order in which these things are presented, it's the same idea as when we're talking about congruency. All right. If you have one side looking at this 21, then you got the next side, it's got to be the angle between them. Okay, side angle, side similarity. That angle is between the two pairs of sides that you're talking about. Okay, so it's all the same thing. Corresponding sides got to be equal proportions, and corresponding angles have to be equal. And so we got two new ways to show these two triangles are going to be similar if you have this proper information set up. There is one example, a story problem that we will do in class. Other than that, this is it. Have a good night.